Okay, for section 6.1 and 6.2, we'll go over the textbook notes. So let's start with 6.1. So 6.1, it's all about the slope-intercept form. So I have another little window open here, right here. Okay, so how the slope-intercept form looks like, and I believe you've probably worked with it in the past, is y equals mx plus b. This is how the form looks just in the variables without the numbers in. So y and x are just the y and x points on the slope, right? So that could change depending on where you choose a point on the slope. The m here is the actual slope, the rate of change that we went over in the previous class. And then finally, this b portion, this is the y-intercept. Okay, so this is basically where where the slope lies on the graph when x is 0. So on the vertical axis when x is 0. And we'll look at a few examples of that. So slope-intercept form, y equals mx plus b. Okay, you got to be very familiar with this form. And we're going to be talking about going from one form to the other and that sort of thing as well. Okay, so let's go back to the notes. Okay. Okay, slope-intercept form. I'm gonna skip this introduction bit here, and then we'll just jump into the information. So on the next page, but y-intercept again, what we just mentioned. Y-intercept is when the x value is 0, and the slope-intercept form looks like this: y equals mx plus b. Okay, and we're gonna play with that as well. Okay, so here's a little bit of another little warm-up, I guess. On the left here, you can see that uh, you might get a graph in a question, right? And they might ask you to find the slope, okay? And then finding the slope, it's just defining the change in the y over the change in the x. So, um, you pick 2 points in the y and subtract them. And we'll go into a little more detail in the questions on the right here. So you have to find the slope from the graph, or you might need to find the y-intercept. And again, the y-intercept is the point where the slope hits the graph when x is 0. So x is 0 right here, right? So at this point, and you just go up or down until you hit the y-intercept. You go up. So this point is 1. So that's how they got 1 here. Okay. So you know that b is 1, right? And then you calculated m, right? So m, you can use any 2 points on the y. So for example, say I used 0.5 here, and then I used 3. 5 minus 3 gives you 2, right? And then you can, on the underneath, you need the x, right? So 2 minus 1 gives you 1. So 2 divided by 1 gives you 2. And that's how they got the slope m here. So we'll try that again with another example. Might be a little more clear. So again, so first thing, pretend they gave us the table of values. Okay, if they gave us a table of values, you just plot it on the graph, and then you just connect the dots, right? And then if you wanted to find m, the slope, again, pick 2 points, y2 minus y1 over x2 minus x1. So hopefully you kind of get that from the previous chapter. So y2 might be 3, y1 might be 2. So 3 minus 2 is 1. And 1 divided by the change in x, 4 minus 2 is 2. So 1 over 2, and then that's how they got the 1 over 2 for slope. The y-intercept being 1, you go to the point where x is 0. So x is 0 right here at this point. You go up and down. X is 0 here, but we want to go up because that's where the slope is. So here the slope is 1, right? And then I got the 1 there. So we got the slope, we got the y-intercept, and that's all you need. When you write the equation in the slope-intercept form, you leave y and x alone. Okay. And with this equation, now you can figure out, like someone's asked, where is the x point when y is 6. And then you just plug in 6 and you can calculate, you can isolate for the x. Okay. So a few more examples, if that didn't make sense, you can read them. Otherwise, we'll go into the actual example. So this is just like a warm-up from the previous section. Okay, so write the equation of a line in slope-intercept form. Okay, write the equation of a line in slope-intercept form y equals mx plus b. So again, this is the same sort of thing we did on the left here. So you see your graph here, right? And this goes into a little bit more detail, so you can see the steps as well. So we want to write y equals mx plus b from a graph. First thing you want to calculate is m, and then you want to calculate b. Okay, so b is going to be super easy, but M, you're just going to pick 2 points on the slope, right? It doesn't matter where it is. Okay? It could be here and here. It could be up here and over here, but it doesn't really matter too much. Okay? So y2 minus y1, x2 minus x1 is the slope, right? Or rise over run. So they pick 2 points, right? So they picked for y2, they pick -1. So -1 down here. So again, if you're picking 2 points, just pick something that lies on these little right in between the cross, because then you don't have to deal with decimals, right? If you pick something here, you're gonna have to deal with decimals or fractions. So -1, and then they also chose 1 here. So they chose this point, right? And then you do the same thing for the x, it's the exact same points. And then you subtract them and you get the slope, -2 over 3. And this makes sense because the slope is going from the top left to the bottom right, meaning it has to be a negative slope, right? So this should be just as how you did before. Okay, now you got to calculate b. Okay, b you could just look off the graph. Okay, where does the y-intercept when the x is 0? So it's right up here, right? So b is going to be 1, right? So they got -2 over 3x plus 1. Create the graph using technology. We're not going to really do this. So if you get a question like this, you can just skip it. Okay, so don't worry about it. If you do have a graphing calculator, you can just plug in this equation that you created and it'll graph it for you. Okay. Okay, this is your turn. It's the same thing. So hopefully this example made sense. You know, if you should know how to do calculating slope from the previous chapter, but if you don't, I can just let me know. We can go through it together. Okay, so you might get questions like this in your homework and your tests and assignments. Graph a line using a slope and the y-intercept to sketch a graph of each line. Okay. Y equals 3 over 4 x minus 2. So let's jump into that. So when you're going to sketch this graph, you know the slope is right here. The value m, right, is the one next to x, and you know the y-intercept is -2. Okay. So what you would do first is you start at -2, and there's going to be a point there because you know that's where the y-intercept is. And from this point, all you got to do is use a slope. This is rise over run. So you go 3 up because it's 3 over 4, right? 1, 2, 3, and then 4 to the right. 1, 2, 3, 4, and you do another point. Okay, and you could do it one more time. I say just as long as you have 3 points, that's enough. So you go rise 3, 1, 2, 3, and over 4. 1, 2, 3, 4, and then you got those 3 points, and you just connect them using a ruler. Okay, and then you got your graph. So let's try that again if that didn't make sense. B, y equals -3x. Okay, just notice that there's no b here. That just means that b is 0. Okay, so at the point 0, so right here you can see there's going to be a dot here. Okay, when the x is y is 0, right? And x is 0. So you put a dot there. And then now you know the slope is -3. Okay, remember -3, just the same thing as -3 over 1, right? So right here it says -3 over 1. So again, rise over run, but now we're going to go downward. So instead of going, when it's negative, and when it's negative, you go right whatever it is, and down, right and down, right and down. When it's positive, like this example, you go right and up, right and up. So just make sure your slope is going downward and it's negative. So once we got our point at the 0 mark, then you go, so rise over run. So rise is 3. So in this case, it's negative, so we're going down 3. 1, 2, 3, and the run is 1, 1. And then we do it again. Down 3, 1, 2, 3, and over 1. Okay, dot. And you connect the lines, and then you got your graph. Okay, it should be kind of easy. We'll go through 2 more examples, same sort of thing. C, we'll look on this page, I guess. Y equals -½ x plus 4. So right off the bat, you should know it's a negative slope, so it's going to be going downwards, and you know it's +4 for the y-intercept. So when the point x is 0, again, x is 0 here, y is 4 for the b value. So you go up 4, 1, 2, 3, 4, and you put a dot here. So this is your first point. And now we're just going to go rise over run. So again, down 1 because it's negative, and then over 2. 1, 2. We got another dot. Down 1, over 2, dot. And then you draw your ruler with lines, and you can just also put the equation on the graph itself as well. Okay. Okay, D. Compare the equation to the form y equals mx plus b. So equation D, y equals 6. So this one might be kind of look tricky. But again, if you're missing a variable, like just how we were missing b in And then part B, right, it's a 0. So x is 0. So that just means it's the same thing as writing y equals 0x plus 6. So start with the 6, which is the b value, go up 6, right? And then how does a 0 slope look like, right? And you should remember a 0 slope is a horizontal line. So that's how they drew the horizontal line. Again, at this point, we're not doing any rise or run because it's 0, right? 0 is a horizontal line. Yeah. Okay. So this is your turn. You can practice this, but you'll probably get more practice in the homework, so you can kind of skip that over. Okay. Okay, example 3. So I think that's all the new information. Now this example is just going to go into a word problem. So we'll try one word problem. I think there's there's 2. So we'll do the first one here. You're not going to get too many. You probably get 1 or 2 word problems on your homework and maybe 1 or 2 on the test. So let's go through this together. Model and solve a problem using equation in slope-intercept form. Submarines must withstand tremendous pressure on all sides from the water. The table shows a linear relationship between pressure and water depth. So you got, the deeper you go in water, the more pressure the human body faces. And yeah, this is kind of cool. There's like diving competitions that have to take extreme precautions because of all the pressure that you're facing. But yeah, let's just sketch a graph of the data. Okay, so when you got a table of values, you could just think of this as the like x value and the y values, right? So you can see that on the right here, water depth in meters is on the right x-axis, and you just choose a value that kind of makes sense. So it goes from 0 to 100 here because it's 0 to 75 on our table of values, and then pressure, is going up from all the way from 0 to 1,000 here because our data is between that range. So you want to choose values that kind of spread your graph over the page or over a large area. Because if you chose like 0 to 1,000,000, this graph will be super small, right? So anyways, so to plot the graph, there's not much to it. So you're just going to use these as x and y coordinates, x and y. So when water depth is 0, pressure is 100, right? And again, this is going to be the b value, right? Because x is 0 at this point, and when x is 0, y is 100. So that's our b value when we do the equation later on. So plot the other 3 or 4 points, and then you can connect the line. Okay. Determine the ratio of a vertical change to the horizontal. So the ratio of vertical change to horizontal, again, that's just the m, the slope. Okay, slope. Once again, change in y, this triangle means change, over the change in x. So 250 divided by 25. How did they get 250 and 25? They just chose y. Remember, this just means y2 minus y1 over x2 minus x1. So you just choose any 2 points and you subtract them. So it says what values could you use to calculate the change in y and change in x? You can choose pretty much any 2 points here. You could choose this point and this point, or this point and the one at the bottom. It doesn't really matter, right? They're all in the slope. So if you look at the table, we can do this in our head. So say we choose the point 4 is our y2, x2 and y2, and then first point will be over here, right? So we're using these 2 points. So 850 minus 600 gives us 250, so 250, and then on the for the y at the top, and on the bottom it's going to be 75 minus 50 gives us 25. So 250 divided by 25 gives us 10, and that's kind of what they got. And you would have got the same thing if you did anything, right? So even if I chose a different point, say I chose this to be our second point and this to be our initial point, the first point, you can do 850 minus 100 for the y gives us 750, and then you got 75 minus 0 gives us 75, so 750 minus 75 also gives us 10, right? So you'll still get the same slope. Okay, part C, it says determine the value of the parameter b. What does this value represent? So simply you can just look at the graph here, and then it's 100, right? The b value where x is 0. And what does the 100 represent? It just means that when the water depth is 0, right? So you're not going in the water, it's going to be 100. And this 100 just means like the surface water temperature, or I guess you can kind of think of that atmospheric temperature, right? The surface of the water. So at what is 100, which makes sense, right? Because we're not diving anything. We're at 0 meters depth. So at the very surface, it's going to be 100 kilopascals, kPa kilopascals. Okay, D. write an equation that models a relationship. Okay, to write an equation in the slope-intercept form, remember it has to look like y equals mx plus b. Okay, m we just calculated, which is 10, and we did also look in the graph for b is 100, right? So y equals 10x plus 100. So that should make sense. So that's pretty much it. And then you can change the letters to say P and D. This is just because we're looking at pressure and the distance, right? So yeah, whenever you're looking for a distance, it's usually this lowercase d, and the pressure is usually this uppercase p. So not much to it. Okay, what does E say here? The last little bit here. Okay, the deepest point on Earth is Challenger Deep in Marina Trench. Marina Trench. The trench is located in the Pacific Ocean. In 1960, the research submarine Triste reached the bottom of the Challenger Deep. At this depth, the walls of protecting the two crew members had to withstand a pressure of 109,300 kilopascals was approximate depth of Challenger. So when you get a word problem like this, there's a lot of big words, and sometimes even me, like I kind of zone out sometimes when there's this much text. Just note that you need to kind of learn how to kind of ignore a lot of the useless information. Well, it's interesting, but it's not. You don't need it for this math question. So all you really need to know is, okay, I see this number, kilopascals. They gave it to us, and now they want to find us the depth, right? So we already created our equation. So you can simply just plug this into our equation and then solve for depth. So the equation we had here, we created in part D, you just plug in for P because it gave us the pressure 109,300 equals 10D plus 100. Once you have this, now just simple algebra to isolate the D value to find the depth. So minus 100 both sides, you get the 100 to the other side. And then once you do that, then you're going to get the D off, it says 10 times D, right? And then the opposite is to divide. So divide this side by 10 and the left side by 10, and you get the distance is going to be 10,920 meters. Okay, so that should be it for 6.1. So all you really need to know how to do 6.1 is how to, from a slope-intercept form, how to create the graph, and also from a graph, how to get the slope-intercept form, right? So we looked at that. Yeah, okay. Thanks, and we'll move on to 6.2.